How are you doing today?
Hi, how are you?
Good. So you finished up the EDX class.
Yes,
Good
was
job.
too was too difficult. The last,
What
the
did you
last
think of what did you think about FlexB?
more easier tool to build complex robotic system.
Yeah, pretty neat. I haven't built any. I've only taken a class on it, but I haven't built anything with it yet.
I will share the final project of the course with you.
Okay, you want to share your screen?
Just prepare the command. Have you read what I written about Hortibot?
I took a look at it. It looked like an interesting machine, and it's neat they switched different companies.
Yes.
Looks like a good design.
I think. Just 1 minute.
Okay.
All these states.
Wow.
The robot start from here, and each state, if failed, it will end in this point. If not failed, it will continue all this until it reaches the finish.
Wow. So did you test this in simulation?
Yes. Gazebo is making laptop to
Overheat?
overheat. I have taken a video for the simulation.
That'd be neat. Post the video of your project into the Slack channel, see what people think.
It's about 13 megabyte. I will try to upload it.
What did you like most about the class?
What? What?
What did you like most about the EDX class?
Taking you from the beginner's level to this level in 6 weeks. That's a great thing.
Yeah.
You see the video?
Yes.
The conveyor belt start moving until these boxes is detected by something called logic camera, a concept in simulation. This camera. Okay.
Yep.
Then turtle boat comes near this manipulator. It will drop the box for it.
Very nice.
Yes. Takes all the day to build this. The other camera detect its position. I have learned about transformations and TF2 package. Then the manipulator pick the box and finally place it in the final stage.
Great job.
Thank you.
That looks really cool.
Thank you.
So now you can see in your robot sprayer the different tasks and turning on and off sprayers and driving to different locations.
When I returned to the QuickBoot package I have worked before, I found that the man who wrote this package make a state machine like that one with FlexiB, but he made it by coding, not with a GUI like FlexiB. I will show the node for the state machine node. Here is the state machine node.
So this is the same thing as FlexB, but doing it just by the code itself.
Yes. FlexiB generate this code automatically, but instead we use a GUI. The error in this package was service was not declared.
The service wasn't started before this
Yes.
was starting up.
Very simple error.
But yeah, there's always a lot of little simple errors that can take you a while to work through.
Yes. In the course, I still one day trying to solve a small issue about something in the moved package called moved commander. Did you hear about it before?
No.
It's just a GUI to move your manipulator and give commands for it to move.
Was
The
it
error,
not starting up, or what was the error?
a small thing, a very, very, very small thing. I have found a complete project about detecting row crop. Here is it.
Very good.
Yeah, they are using many approaches to solve the problem, not just half transform. They are using many approaches. واحد.
Is there a GitHub project for this paper?
Yes, I will share the link. I will post the link in chat.
Okay. What did you like about this paper?
I think I will try to use it. Now I am taking all my consideration in the control and navigation. Here is the link.
You've had a pretty good couple weeks then. You
Our
feel like
folks-
you're making some progress?
Yes, in the mechanical design, we have taken a lot of discussions to take a final decision. As you know, design is a phase that you can almost modify it according to the available resources.
What type of camera do they use for this row detection?
I not remember. But the thing that stuck in my mind, the computational power they are using. They are using a Core i5 processor.
Excellent.
Yes.
Not too heavy.
You can find it in the README file. .5 gigahertz Intel i5. You read it?
Yeah, 2 gigabytes of RAM.
Yes.
And it's 32 millisecond processing time for each image.
Yes.
Well, that's really interesting.
Good
He says he can pick up the rows 50% of the time.
What?
And he says he's getting about, the algorithm can detect about 50% of the rows.
Yes.
Really interesting. That's nice that he puts the images up there, and it's nice that it's in a GitHub account so you can take a look at it, see what you think.
You think about what?
It's really nice of Peter, the guy that wrote the paper, to make a GitHub repository with the software.
Yes.
Very helpful.
Open source.
Yeah, yeah. That helps in the learning process if you can see the software and see how it's put together.
Yes. This is what will make robotics cheap technology in the future.
And faster for people to adopt.
Yes.
So there was some talk, you're going to put an i5 on there on your robot. I'd be curious to see how fast it runs on a Raspberry Pi.
I didn't try it until now, but the cost is what restrict us.
Yes, the 32 milliseconds is pretty fast. You're getting an update pretty quick.
You have worked on a similar project before?
Not in crops, only on road vehicles for lane detection for the that type.
For the machine learning, some people advised me to use open source like TensorFlow. What do you suggest for this?
Yeah, TensorFlow and ROS is pretty powerful. Yeah, I would go with that if you were doing machine learning. Or if you want to.
No, I haven't tried to do this.
There's really good tutorials on the Construct has some tutorials on how to lay out TensorFlow and how to incorporate that. They do it with like a face detection algorithm, but you may be able to change that to a plant detection algorithm, just different images, filters.
Yes, I will search about it. Have you seen the new Hortibot?
No, you want to show?
I will show.
You emailed the guy and asked him what they're doing with it?
Yes, I have sent an email, and I was surprised that he replied quickly. He replied within just 12 hours.
Awesome. So are they going to take this robot to market? That's the plan?
He write just 2 lines in the email. The robot is in commercial use, and he sent the link of the company.
Okay. That will be similar to what you want to build and do?
Not in all details, but the concept is the same. This is a company.
Wow.
And this is the robot. The simulation.
And they're out of Italy?
What?
Are they in Italy?
Norway.
Norway.
Yes.
Excellent.
Searching and God guide us.
Yeah, it looks like they're doing the same road detection, driving up and down.
Yes, I will try to get the specs of this robot. All the robots now are using hydraulics. Nearly a few numbers are using electric motors.
So what was that first one? Most of them are using what? Hydraulics?
Yes.
And then the second is electrical.
Nearly all robots now are using hydraulics in the wheels. The research robot Bunny Rob are using hydraulic motors in the wheels.
I was pretty impressed with that Lee Classic sprayer. That one only has like 20 horsepower engine.
Yes.
They're using hydraulics for the motors, the wheel motors also.
When you see robot now, you will be more.
Pay attention.
Yes. The engine was. I will give you the number now. 20.4 horsepower.
That's that's small. Not much gas.
Here is the link.
Have you decided if you're going electric or hydraulic?
The cost. Only the cost. I have shared the link in chat.
So they're running a 20 horsepower diesel engine?
20.4 Kubota engine. Diesel engine. This one.
Oh, Kubota. Yep.
Here is it. 20.4.
Wow. Did you call on the price for that one?
I don't think it will be suitable for us. But comparing the dimensions of the robot with this bar, I think they are perfect.
It's a good matchup.
So it's see the dimensions, width and length, very big robot.
Yeah.
And it is about 1 ton. Its weight is about 1 ton.
That's pretty good size.
Yes. A good design.
Are you looking to make the similar size robot?
We are working to make one like the least rare, but with suitable solutions for us.
Excellent. So now that you're done with the EDX class, what's the next step?
Start the coding.
Yep, now you're ready to code.
Yes. I have worked to analyze the QuickBot package and understand all its components. When I told you that the error was in the service, I was shocked. Very little error.
But now you know, so you won't, that problem won't stop you again, because now you know that what it looks like.
Yes. These mistakes makes one learn.
Yeah, it's working on patience.
Yes. The big challenge now is to design the human-machine interface.
You find any, so a lot of people are using web-based UIs. Use like the ROS bridge.
I have tried to use some mobile apps to get the camera from it, but I think cloud systems and these systems will not be suitable in rural areas.
Yeah, you're going to need to connect directly to the machine instead of going through the cloud and coming down.
Yes.
But yeah, so what did you think about your UI design?
Only the RF, only RF.
Yep, RF is okay. You can still use a web bridge over RF.
Have you see a project like this before?
Yeah.
Using RF in communication with. Please give me a link for this.
I don't have a link for it.
And,
But most of my experience in robotics has been just over RF. Most of the farm fields that I've worked in, they don't have cell phone coverage or very poor cell phone coverage. So we just go directly to the machine over radio.
can you give me a technical brief?
Yes, I can. So on the robot side, we use it's a IP radio, but there's a couple different radios to look at. And then that connects into your base station Wi-Fi radio.
IP, RF on the robot?
Yes, yeah, like a Ubiquity Bullet or a Microtech 2.4 gigahertz radio. I'll post the link up.
Okay.
So basically, your base station needs to have a radio, and your robot needs to have a radio. And you can use the 2.5. 2.5 is a pretty good frequency. There are other people on 2.5. This is in America. America, we've got certain frequencies that are public. So 900, 2.4, and 5.8 are the general frequencies that we use. I don't know what they are in Egypt. But this radio I sent you is a 2.4 gigahertz. What's nice about using 2.4 is that your laptops, it's just like connecting to a Wi-Fi. So you're basically just setting up a Wi-Fi bubble out on the farm. And so your base station has an Ethernet radio, or your router that your base station is connected to has one of these Ethernet radios, and then your robot also has one. But what's nice about using 2.4 is that if you have your laptop and you're out at the robot, you can still connect into it, or it's open.
This is about the communication itself, but the interface.
Like the UI, what the UI looks like.
Yes. How it's built.
What was that?
How it's built.
How it's built. So it depends. If you've seen the robot web tools. I'll post a link here. So a lot of people are just using a web browser. I mean, like a web UI.
Web UI.
ROS Robot Web Tools. So I posted a link in there for the ROS Robot Web Tools, and this gives you some ideas of what you can do with it as a ROS bridge to a web page.
Okay. I have worked before on RF with Arduino, just a little project. But the amount of data that can be sent is, I think, is very low.
Over RF?
Yes.
Well, it just depends. So you're using RF sometimes if you connect to a laptop and connect to your home router, same exact thing. So you can get fast enough speeds.
Depending on what?
Do what?
Depending on what?
Depending on, okay, so like if your robot is, so what's different about your home router versus going outside and setting up a Wi-Fi hotspot at a farm is you have to pay attention to like buildings and trees, things like that will make your bandwidth drop out. So the way that you deal with that is you have a very tall antenna on your base station. You're basically trying to create a Wi-Fi bubble on the farm. So depending on how big the farm is, you're going to be limited by how far away you can get away from your base station. And then if there's anything blocking the signal between your base station and the robot. So if there's like a line of trees and your base station is on this side and the robot's trying to drive around on the other side, your signal will degrade. So you have to watch that. But if it's an open field like those beet fields, everything is low and then you just have line of sight. So you'll have very fast rates.
Okay.
There's ways to increase the bandwidth also by using like two channels. You can, and you want to have very good antennas. A high gain antenna is very helpful, flattens out the signal.
Okay.
The other way to work in that environment is to use a meshing radio. So meshing radio will pass a signal. So you know, like a star design, you have a middle one and each of the radios have to connect back into this one. But if you use a mesh radio, then if you get to an area out in the field where the signal is too low, all you have to do is just add another radio and then it will extend the bubble. And those MikroTik do meshings.
Okay.
Any other question?
Thank you very much for this good information.
There's higher grade radios. This MikroTik is more of like a commercial style radio. The setup is a little bit more difficult. The Ubiquiti M2 bullets are pretty easy. They're commercial and they go together pretty easy. They're not meshing though. Okay. So how far you need to go is really dependent on what's going on in the area. So for example, if you're using the 2.4 frequency here in America, if you go out to a field and somebody else is broadcasting on that frequency, then that will hurt your signal.
Yes.
So it's kind of like a farm by farm basis of what you have to do to make it work.
Yes. Okay. To summarize this, I will use RF and try to build using the interface using web tools. Yes?
That's an idea. I don't know, but that's one way. Sometimes you can. The other thing is how much data you're moving back and forth from your base station to your robot, and so if more work is done on the robot side, then there's less data going back and forth. But that may take some experimenting to see what's the right level. So for example, you can put a little web server on the robot. And so when you pull up a web page from your base computer, you're actually pulling up the web page off that's sitting on the robot. And so when you're sending data back and forth, you're just basically sending clicks, sending small little bits of data to the robot. So it doesn't take up much bandwidth.
Okay.
Versus having that UI run on your base laptop. Then there's more data going back and forth.
Okay.
I don't know exactly for sure or how much the difference is, so that may be something to look at. We haven't made it to the UI part yet.
What?
We haven't made it that far to to make a user interface yet. With the lawn tractor, we don't have that yet.
Yes. To what have you reached?
Basically, driving autonomously.
Using G-mapping and
GPS and wheel encoders, steer angle.
the software package.
Yep.
In the course, I have learned to use G-mapping.
To build maps?
Yes.
Using laser scan?
All the material in course was just a simulation.
Do you know how accurate you want the position, your robot position to be? I mean, like, you need it about an inch, maybe? Or
the line, the crop row width is about 45 centimeter.
Okay.
Between each row is 45 centimeter.
Okay. So are you? Oh, we haven't got to the part yet where you mix the GPS and then the vision system to guide the down the row.
I am searching for it. Now I am working on the model of the articulated steering and how to modify the package of the quick boot. First, how to launch it on the hardware and make it working. Then, how to write one for the articulated steering model.
Yep.
How do you see this progress?
I think it's excellent. You're doing great. Yeah, I think that.
Motivation.
No, well, I think that EDX course was great, and using FlexB, that's going to come in handy to give your robot tasks. I think maybe some of the challenges, don't know, just a guess, is the localization. You'll have maybe a GPS to drive your robot out to the field, and then as you start to get closer to the rows, then switching over to the camera system to drive down the rows.
Yes.
Localization can take some time to figure that part out. We did put up on the ROS Agriculture GitHub site, there's a package called Tractor Localization, and we tried to document how you use the IMU and GPS to find, with robot localization, to find your position. We're still kind of working on a complete package for robot localization. We don't have that done yet. But maybe that's something that we can work on together. Maybe the lawn tractor people, we can work on the GPS IMU wheel encoder part, and then we can work on fusing with the vision system for accurate position.
I wish I can finish this project in July and work with you.
Oh, it'd be fun. We got to find a farmer who wants to do that, and we can build it out for them.
I have found a link for business. They are making a study that agriculture robotics will become industry in 2038.
2038 is a long time.
Yes.
At ROS Agriculture, we're hoping that it will happen sooner.
But the number of money is something big.
Do you see those robots there, those two tractors?
Do you see this number?
Yeah, but you see those tractors, those going down the vineyard in that picture? Those are the tractors that I used to drive around.
In ASI?
Yeah, that's me. I'm driving them from the control station, but I'm not in the photo.
That's great.
And those robots run over RF. On this blue tractor that you can see near the top left, there's a little black antenna, and that's running
This
just
one?
an RF. Yeah, that's an RF antenna.
Okay. And what is this?
GPS.
Yes.
Yep.
But did you see this number?
35 billion. Yeah.
Something.
Yeah, sure. It's a huge. I think globally it's like $1 trillion.
Now?
Now, yeah. Agriculture's huge.
Yes. I will share this link in the chat.
Okay. Yeah, we haven't even started to see them out in the field yet. This is still new. Maybe 3 to 5 years we'll start to see them start popping up.
I think it will a little bit
Sooner.
sooner.
Well, thanks to you, you'll have a robot out running around sooner than 3 to 5 years, so that's good.
God will help us.
Yes. We need it. Yeah, I think it's exciting. Agriculture is a great space to be in. It's just turning over right now. So 20, 30 years from now, we're not going to recognize it.
I have two dreams. The first one is to build a business. The second one is to write the first book about agricultural robotics
Good.
and publish it for free to help people to do something in this field.
Awesome. Yeah, we're going to need a lot of that.
I can't find until now a specific book for agricultural robotics.
I've seen reviews, but mainly just papers.
No books. It will be great to find, if anyone wants to start this field and found a book, this will save a lot of time.
It'll really help them out.
What?
That will help them out to make it faster. You know, hopefully as we learn, we can make it faster and easier for the next group to come through.
Yes. You told them to learn ROS in 20 years.
Yep. It'll
be a little bit sooner.
Yeah, it'll be sooner here.
Thank you very much. The video of the project of the course is a little big, something big to upload.
Sometimes what I do is I just upload the video to YouTube and then post the link to the YouTube video in the Slack channel, so it doesn't take up space.
I will not need to take a permission from the course instructors.
I don't know. That's a good question. If you're showing the demo, the video that you showed just shows the demo of it driving around.
I will post it. Anyway, I will post it.
Okay.
Okay.
We may have to have you as a guest speaker at the other meeting to go over FlexB when you get it running for your robot in the field.
Why?
You'll be our expert in state machines.
Me?
Yep. Do you want to be the expert in state machines, or you want to be the expert in controls and then localization and machine learning?
I will be expert only in control. This is my best field.
Okay, that's good.
And machines, if you want.
Yeah.
I have studied state machines in the control of mobile robots course from 2 years ago.
Okay.
This makes the course a little bit easier for me.
Already familiar with some of the principles?
Yes, more complex than, but in this course it was just implementation. The theory was explained well in the course about control of mobile robots.
You covered a lot of material in 2-3 weeks.
Yes. Started from move it for manipulators, then the vision part. But as I told you, they used an abstraction, something called a logical camera. Not they make this not to make us go deeper in the computer vision part, just to detect the part and its position, and use this position for the transformation package, TF2, if you heard about it before.
Excellent. So they did it wasn't really focused on the computer vision part of finding the box. The project camera kind of already has the filters to do that.
No, as I told you, something called a logical camera, an abstraction, not a real hardware or just abstraction.
Simulation.
Yes. And after this, using transformation and a useful tool called the transformation buffer to get the location with reference to other reference frame, not the frame of the camera. Yes.
Yeah. The TFs make that easy. I mean, easier because all of that are already set up. You can get the position from whatever frame you want.
Yes. After this, in week 6, we learned about behaviors and how to build them. Then we integrate all this in state machines, the complex diagram.
That's a pretty good layout. It's a good approach.
I can express they are perfect to make this content in just 6 weeks.
You did an excellent job.
Yes.
Do you know how many people signed up for that course?
When I was watching the videos, the YouTube videos watches was about were about 60. But now all my colleagues are trying to study it.
That's good. Pass the information on.
The last video in the course watches is about now about 100.
Okay.
But they told that students with good grades in the course and the good coding will apply their code in real hardware in TU Delft University.
Ah, that's neat. You get to see it run in action in real life.
Yes. I will show you the last video in the course.
Okay.
Making an online course is an experience that is very unique, and all of you remote learners are an integral part of this experience, from whom we get to learn so much. On behalf of all instructors and the administrative staff, I would like to extend our sincere thanks to all of you for your active participation in this course. We are really happy to see so much interaction on the very first run of this course. Over the past weeks, we learned from you through your feedback, criticism, and discussions on the forums. And these learnings are extremely useful in our pursuit to keep improving the course for future runs. We hope you all enjoyed learning about different ROS tools.
Just this number. Do you see it?
Yep.
72.
Okay. That's a
When
good
I
way to look.
did it was just 50.
Well, maybe some people are still working through the material and they'll grab it.
Maybe. The course has nearly 1 week rest to submit the assignments.
So how many people do you have on your team now?
Difficult question. If I told you, very difficult question. Only 6, and they are decreasing.
Well, maybe we'll get some new ones here.
I wish we can get more people, but I don't know if the project is difficult or what is happening. What people are decreasing.
Is it too much work, you think, or too complex?
I think the problem, the difficulty in this field.
Yeah,
If you
it's
are
very
not
difficult.
yes, if you are not interested, and this is your goal, you will not continue in this track. It's too difficult.
Yep. Yeah.
One day I will, inshallah, I will write a book for this.
Adventures in making a beet spraying robot.
This will be a title of the book.
Yeah. Yeah.
Okay.
Well, you're still on track to complete the project, though, right?
Yes.
Good.
It's my life.
It's your life.
Yes. This was my dream for since 5 years, when I was about 18 years old.
That's awesome. You're making it happen.
Thanks to God.
Yeah. Yeah. You're making great progress. It's neat. It's good to watch.
As I told you, it's my life.
When do you graduate?
Next July.
July. Okay.
Here in Egypt, we have a lot of challenges. One of them is reclamation.
Reclamation?
Yes.
Buying
New land.
parts?
What?
Buying parts? What do you mean by reclamation?
New lands.
I didn't hear.
New lands.
New land. Yeah. So like reclaiming desert areas or poor
Yes.
soil areas. Great. Good
This
job for a
issue,
robot.
this issue is the most suitable solution for robots.
Yeah, I agree.
I have went to a place uh, 400 kilometers from Cairo. If I told you the no labors, no labors, difficult to find the labors, difficult to no utilities. Uh, if this robot is built using solar power, this will be more efficient.
Is there diesel out there?
Far near to find the station is about 100 kilometers.
Wow, long way.
Yes,
So
this
maybe solar
station,
power.
solar power is here in Egypt will be a great field in 10 years. Many people are using it now.
Yeah. So you think setting up like a solar charging station and then maybe the robot has one solar panel or two solar panels and then comes back to the solar charging station at night or something?
This area will be, the area covered by solar need not will be over the robot. To get, for example, 20 horsepower, you need uh, an area that's big to be over a robot.
Okay.
I don't remember the definite number, but you need a very large area to make 20 horsepower.
Okay.
But reclamation, as I told you,
Yep.
is the most field for robotics all over the world.
Yeah, no labor out there. There are monotonous tasks that you have to
And the
do.
new land,
New
new land,
land.
yes, no compaction, no as God create it.
Yeah. Yeah. Excellent. I that would be great. Good job for a robot.
Yes. If we collaborate and one day this will be grateful. But after, I think this will be after finishing this project.
Maybe in the fall.
Yes.
Have you started talking to anybody that's in the land reclamation area?
Many people, many people. We have talked to many people.
Good. They excited?
Yes. But the only problem is the cost.
Has to be low cost, like maybe $1,000,
Yes.
5,000.
The tractors we are using here, uh, the new tractors, the new tractors cost now is too high. People are going towards the used one to solve the cost issue.
Yep.
In this situation, we need to build robots with lower cost.
What do you
Agreed.
think what is a good price point? Do you think maybe like 5,000 for the whole system?
Something is like the lease prayer in US if it is autonomous.
That thing's
How do you
like
think?
50 grand.
What
The lease sprayer is expensive.
is if it is autonomous?
Okay. Yeah.
What will be its price?
The Lee sprayer here in America, if it was autonomous, maybe 100 grand,
The
100,000.
double of more than the double of its price, the manual drive.
Well, I called on a used sprayer. They wanted 42,500.
This number is too large. When I asked the new one, he told me that it's about 30,000.
30,000 for the new one. Maybe I was looking at a different model, a bigger unit or something.
Yes. The one I have showed you before is 20 horsepower. And
Okay.
I have sent a mail for the company, and they replied with a price offer.
Okay.
But I think is the one you have talked about is a little bit bigger. Nearly the double of the cost. Yes?
What was that? The cost?
If it is autonomous, you will make it double the cost of the manual one.
Yeah, that's a good question. I don't know, because what's expensive about the autonomy kit, the sensors, like the safety sensors, liability, and functional safety. So sensors cost a lot. Like if you want to know inch accuracy or 2 centimeter accuracy, it's for a GPS system, maybe $6,000. That's one sensor.
Yes.
So a 16 scan laser is maybe, I don't know, a couple years ago they were $8,000. So you have 6,000 and 8,000, two sensors,
Imagine, imagine that people here found the new ones expensive. The new
Yeah.
manual machines are expensive.
without autonomy.
Without autonomy. If we add autonomy,
Yeah.
this is the main challenge for us.
Yeah. That's a big challenge everywhere. That's a big challenge for small farm. That's the challenge. We're resource constrained. We have to use cheaper components, and the system can't be as big. Cameras are less expensive, but then you need a bigger computer to process all of the vision data generally.
Okay. Someday it will be cheaper.
You're going to do it. You're making it, Mohammed. Yeah. Mohammed. Yeah. You're going to have a good robot.
I think.
All right. Well, thanks for the update. That looks great. You're doing good work. I'm glad the class went well, and the FlexB looks really cool.
Thank you very much. But please take into consideration that we will prepare the book together.
Yes, for sure. That would be fun. That would be a good project. Yeah.
This will make our community a big and spread and help people to enter this field in a more easier way.
I agree.
An easier way.
That's a great idea. Make a couple books. One book for the lawn tractor, one book for the sprayer.
Make it in one book. For agriculture.
Two or one.
One book.
Well.
Okay.
Yeah, it was good talking with you today.
Thank you very much.
All right.
See you next week. Inshallah.
Bye-bye.
Bye-bye.